Hi folks, welcome to a week 29 level 1 revision video. So we didn't do this that long ago, so hopefully this video won't be too long, but we're looking at recognising and calculating with a scale factor to find actual distance. We're going to go over the basics and then we're going to apply it using some sample questions. Okay, so first of all, a bit of a recap. So for example, on the right hand side, I've got a scale drawing of Thomas the tank engine. It's got to be Thomas because my boy loves Thomas. But we call this kind of drawing a blueprint. So these drawings are to scale, which means that we could calculate the real life measurement if we knew the scale factor. The scale factor is coming next. Maps work in the same way. All the distances are scaled down so that we can see a large area at once. 1 centimetre on a map could actually be worth much bigger in real life, and it depends on the size of the map. So let's talk about the scale factor. You might remember this from a starter that we did not so long ago. We'll go through this one because it goes over some of the basics that we need. So on this map of Blackpool, the scale factor is where it says 1 centimetre equals 50 metres. So it's here. So what it really means is that 1 centimetre represents 50 metres. There's a ruler on here because it was on the starter, but I don't know if you've got a ruler at home. I have no idea. Most of you will, but just in case, I'm not relying on you having a ruler. So let's actually work it out. What is the actual distance from the North Pier to the railway station? So the North Pier is in the bottom left hand corner, and in the top right hand corner there's a railway station. So we've got a ruler on the map, so we're going to use that ruler to measure the distance between the two red dots, and it happens to be 10 centimetres. So let's take a look at the scale then, the scale factor. For every 1 centimetre on the ruler, in real life it's actually worth 50 metres. But actually we have measured 10 centimetres on the map, so we want to know what is that real life measurement. This is use of ratio and proportion. To get from 1 to the number 10 in ratio proportion, all we're going to do is times and divide. So in order to get from 1 to 10, I would have had to have times by 10. So whatever we do on one side, we do to the other. So 50 times 10 is 500 metres. So in real life, the walk from North Pier to railway station, assuming that it was in a complete straight line, is actually 500 metres in real life. Now the way I've drawn it out hopefully explains it to you. You know, you do one on one side and you repeat it on the other side. But if you felt confident that you understood that, let me just get rid of all these workings out. You could just skip straight to it. Well, if 10 centimetres on the map, all we need to do is just times it by the number that's on the right hand side there to give you 500 metres. That works if the number on the left is the number 1. Let's take a look at another one. Calculate actual distance. Example 2. The drawing of this door has a scale factor of 1 centimetre representing 10 centimetres. So for every 1 centimetre on the drawing, in real life it's actually 10 centimetres, so it's 10 times bigger. So what are the actual measurements in real life? Let's look at the height of the door first of all, and I'm going to rewrite out that scale factor. Okay, the height of the door on paper is 20 centimetres. To get from 1 to 20, I would have had to have times by 20. So whatever I've down to the left hand side, I have to repeat on the right. So I'm going to do 10 times 20, which equals 200 centimetres. So in real life, the height of the door is 200 centimetres. Let's look at the width of the door. I'm going to rewrite out that scale factor. So on paper, the width is 12 centimetres. To get from 1 to 12, I would have had to have times by 12. So whatever I do on this left hand side, I'm going to repeat. So 10 times 12 is 120 centimetres. So that's the width of the door. In real life, you could, rather than doing it on the diagram, like I say, you could have just times it by 10, do the shorthand. And if you'd written for your working out times 10, then that's enough. You don't have to do as much as working out as this. Okay, this is the last one we're going to do. It's a bit of a pain, this one, sorry, but one like it is on the sample test, so I thought I'd better do one. Right, Terry walks from Tesco Express to Abingdon Football Club. So we've got a map on the right hand side. So he's starting at Tesco's. Oh, I have no pen at all. That's new. Let's try that again. There we go. He starts from Tesco's and he's going to the football club here. On the map, the distance is 8 centimetres. So this black dotted line that he's walked actually measures 8 centimetres on the map. And we've got a scale factor down here so we can work out how far. Back to the question. It takes Terry 10 minutes to walk 1,000 metres. It's quite a lot. How long does it take Terry to walk from Tesco Express to the football club? Include unit of measurements in your answer. So the final thing that we need to provide is how long it takes him to walk. So, and then it says give a unit of measurement. So you've got to decide when you've worked it out, is this thing seconds, minutes or hours? Before we can even look at how long it takes him, we need to know how far it is first. So we're going to do that part, just like we have done in the previous question. So our scale is 1 centimetre equals 200 metres. And on the map, the distance is actually 8 centimetres. So we're going to have to get to go from 1 to 8, we're going to times by 8. And we do the same on the other side. So 2 times 8 is 16. Add those 2 zeros. So the distance in real life is actually 1,600 metres. Now we need to say how long it takes him. All it tells us is that it takes him 10 minutes to walk 1,000 metres. And that is like another scale factor. So 10 minutes equals 1,000 metres. Now usually our scale factors have the number 1 on the left hand side, and it's possible to, this is a bit like simplifying a ratio, a fraction or a ratio. We're going to get this 10 down to 1. Now in the example to the left, to go from a small number to a bigger we times, but we're going in the opposite direction this time. So to get this all the way down to 1, we're going to have to divide by 10. So we're going to do the same on the other side. And so Terry then, for every 1 minute he walks, he actually walks 100 metres in real life. So this is a new scale factor. So we're going to use that to find out how long it takes him to do 1,600 metres. That's what we worked out. So let's write it out again. 1 minute he walks 100 metres. We need to get this, sorry about that. We need to get this 100 metres all the way down to 1,600 metres. And once we can figure out, well, 100 times something equals 1,600, I can then do the same on the left-hand side. So what is the relationship? Now, just from those numbers, I can see that if I do 100 and I times it by 16, it will actually give me 1,600 metres. if you weren't so sure about that, you could do a backwards calculation and just do 1600 divided by 100, and that will give you 16. So that would be what you times by on each side. Anyway, we've got this little scale factor here, so whatever we do on one side, we do to the other. So 1 times 16 is obviously 16. So it takes Terry 16 minutes to walk the 1600 meters. It's a little bit more involved in that one, but just break it down, find out how far it is, and then we work out how far does he walk in 1 minute. That's what we need to find out so that we can then turn it into a total time, which was 16 minutes. And I think that's the end of this revision video. So to summarize, we had a quick look at what scales were, where they use like blueprints and maps. We looked at scale factors. We did a couple of sample questions, and then this one was quite an involved, detailed sample question as well. All done.